Is humanity the main responsible for the rapid evolution of climate change that intensifies every day? Increasing temperatures, devastating natural phenomena, rising sea levels. Are we to blame for all this? In today's video, we will use NASA studies and tools to understand what is causing climate change, what these changes could mean for humanity, and what to expect for the future of our planet. We are astrogeeks. If you're passionate about astronomy or just curious about the wonders of the universe, this is your channel. Subscribe below so you don't miss any of our videos. Each week, we select and prepare a new video with a different and intriguing theme for you. Together, let's explore the mysteries of the universe. In today's video, we will discover why climate change is happening and what the projections for the future are. To help us understand the topic, we will rely on various studies and missions published by NASA. But first, we need to understand, what is climate change? To summarize, climate change refers to long-term alterations in Earth's temperature and climate patterns caused by natural and human factors. To put it simply, imagine Earth has a natural thermostat that is getting increasingly warmer. Human activities, such as burning fossil fuels and deforestation, increase the concentration of greenhouse gases, warming the planet. This results in extreme weather events, like glacier melting and sea level rise, affecting ecosystems and societies. Now that we understand the basics, we can move on. How does NASA study climate change? As you might imagine, one of NASA's primary ways of studying Earth is from space. There are more than 24 satellites and instruments in Earth's orbit, including some on the International Space Station, continuously monitoring our planet. These satellites have been observing Earth for decades, allowing us to see not only the current state of the planet, but also how it has changed over time. They monitor various aspects, such as vegetation, clouds, rainfall, and carbon dioxide levels. For example, the Landsat series of satellites began observations in 1972, providing us with over 50 years of data about our planet. Landsat shows us land use and cover, identifying areas with trees, snow, agricultural crops, urban areas, deserts, and lakes. With more than 50 years of data, we can observe changes over time, like urbanization and forest area declines in some parts of the world and changes in the size of certain lakes. One of the things we see when observing Earth is climate change. Temperatures are rising. NASA also monitors Earth's surface temperatures. Through this animation, we can see a set of surface temperature data and observe the temperature change over time, starting in the late 1800s and advancing to today. The year 2022 tied as the fifth warmest year on record. Collectively, the last 9 years have been the warmest since modern records began. Temperatures are rising faster on land than in the ocean and more in polar regions than in tropical regions. It's not just temperatures that are rising. There are other climate change impacts we are observing along with these temperature increases. Arctic sea ice is decreasing, sea levels are rising, and we are facing more extreme events, like heat waves and wildfires. The water cycle is also changing, with more intense rainfall in some areas and more droughts in others. The news that arrives every day is not encouraging. Many of these impacts will become more intense or more frequent, or both, as warming continues. This figure is from the latest IPCC report, the Intergovernmental Panel on Climate Change. Here we can analyze the temperature variation of the hottest day at various levels of warming. For example, in 2022, the temperature was about 1.1 degrees Celsius higher than in 2023. This shows the temperature change in gradual increases of 1.5 degrees Celsius, 2 degrees Celsius, 3 degrees Celsius, and 4 degrees Celsius. It's evident that these extreme heat events intensify with future warming. Causes of Earth's warming. We know that human activities are the main drivers of global warming, especially due to greenhouse gases that heat our planet. This new animation shows the concentrations of carbon dioxide on our planet. The colors indicate the sources of these emissions, where browns represent fossil fuels and greens represent more natural sources. We can also see the so-called carbon sinks. When you see the flashing in the southern hemisphere, that's where carbon is being absorbed. Thus, part of the carbon is absorbed by the oceans and land, while the rest stays in the atmosphere and traps heat, leading to the warming of our planet. Methane. Carbon dioxide is not the only greenhouse gas. In this video, we can observe methane. Here, we can see where the methane sources are around the world. Methane has different sources compared to carbon dioxide, coming from activities like agriculture, oil, gas, landfills, and wetlands. Methane is also a greenhouse gas. It is more potent than carbon dioxide and can lead to air quality concerns worldwide. About 3 years ago, NASA placed an instrument on the International Space Station to help identify methane. This is an image of that instrument, called EMIT. EMIT was designed to measure mineral dust, which are fine particles that reflect or absorb sunlight depending on their color. Mapping this dust is EMIT's goal, or at least it was its only goal. The science team realized it could also observe methane using the instrument. Here is an image of this observation, a methane plume over the southwestern USA. Impacts of climate change. The temperature increases we are witnessing have significant consequences for climate change worldwide. Let's explore some of these impacts and discuss what we can expect in the future as warming continues. We can start by analyzing the data obtained from the GRACE and GRACE-FO missions. These missions use a pair of satellites to measure changes in Earth's mass, allowing us to observe alterations in ice sheets and terrestrial water storage. We observe a decrease in the mass of ice sheets in both Greenland and Antarctica due to global warming, while the time series shows an overall mass loss. Examining individual maps of these regions highlights areas with significant ice loss and areas with gains. The melting of ice sheets directly contributes to sea level rise. The presented graph shows a continuous increase over time, reflecting satellite observations since the early 1990s. Besides ice melting, the thermal expansion of oceans due to warming also plays a significant role in this sea level rise. And as bad as things are, they can get worse. Sea level rise is not the only impact we have. Here, we can see extreme events. This particular animation looks at wet and dry extremes. We can notice that with increases in warming, we also have more intense rainfall events and, in some regions, more droughts as the water cycle is changing. This animation shows an index of the total intensity of these types of events, looking at their duration, magnitude, and affected area. The blue points are where there is an increase in wet extremes, and the red points are where there is an increase in dry extremes. We are seeing both around the world. Thus, we are witnessing increases in heavy precipitation and flooding, as well as increases in droughts in some parts of the world. What to expect in the future? These are the impacts we are currently experiencing. But what many people really want to know is what will happen next. This is another figure from the latest IPCC report looking into the future. Here, we can see that the reds and darker reds represent hotter years, while the blues and yellows represent cooler years. What we can analyze is that it largely depends. How much hotter it gets in the future depends on emissions. Therefore, there are different scenarios depending on how much more emissions we will have in the future. Higher emission levels mean more future warming. We can see how this looks over time and map out what we expect some of these impacts to be. But, with increases in warming, we expect more impacts and more warming with higher emissions. NASA's actions regarding the problem. NASA plays a crucial role in mitigating and adapting to climate change, focusing on research and developing technologies to reduce aviation's environmental impact. The aeronautics team works on designing more energy-efficient aircraft and optimizing airport operations to reduce emissions. What many people don't remember is that the first A in NASA stands for aeronautics, meaning one of its major focuses remains reducing the environmental impact of flying. Additionally, they are exploring how their research and tools can be applied to address challenges caused by climate change, such as wildfires, using unmanned aircraft systems for effective observation and response. Remember that all the Earth observation satellite data we showed in this video is publicly accessible on NASA's website. We will also include all the links to the sources used to create this video below in the description, reinforcing our commitment to and seriousness about disseminating validated information. If you learned something new in this video, don't forget to support our channel. Click the subscribe button below to join our community. And of course, if you enjoyed this video and the information we shared, leave a like, as it really helps us continue bringing interesting and intriguing content like this. Thank you for joining us here at AstroGeeks. Together, let's keep exploring the wonders of the cosmos. Until next time, and don't forget, always keep your eyes on the sky.